Hello friends, this is the sixth lecture on applications of derivative, and in this lecture I will explain 10 examples. Now let us start. Applications of derivatives. The topic is same, that is the equations of the tangents and the normal to the given curve. Same formulas are here. This is the tangent to the given curve at the point P, and the normal is perpendicular to the given curve. I am adding some more examples of derivative as a rate measure. If y is a function of x, then dy by dx represent the rate of change of y with respect to x. If x is equals to f of t, then dx upon dt represent rate at which x changes where t is a time. Next is, let the displacement s of particle be a function of t, then velocity v is equals to ds upon dt and the acceleration dv upon dt. Also we can write dv by dt by the chain rule, dv upon ds into ds upon dt, and that is nothing but the v into dv by ds, and therefore acceleration is equals to dv by dt is equals to v times dv upon ds. Now let us start the examples. A particle moves according to the law x is equals to t cube minus 6t square plus 9t plus 5. The displacement of the particle at the time when the acceleration is 0. इथे आपल्याला displacement दिलेला आहे, त्याचा first derivative find out करणार, that is nothing but the velocity. Second derivative आपण जेव्हा find out करणार, that is the acceleration, and we have given the condition that the acceleration is 0. Okay, this is x is equals to t cube minus 6t square plus 9t plus 5. Differentiate this with respect to x, with respect to t, then you will get here 3t square minus 12t plus 9. Acceleration dv by dt is equals to 60 minus 12. We have given that the acceleration is 0, means what? dv by dt is equals to 0, that is a 60 minus 12 is equals to 0. Then you will get t is equals to 2, and hence the displacement when the acceleration is 0 is, substitute t is equals to 2 in this expression, then you will get x is equals to 7, and hence option C is correct here. Okay, easy question hai to. Next, the displacement s of a particle at time t is given by s is equals to 1 by 3 t cube minus 1 upon 2 t square minus 6t plus 5. Then its acceleration when velocity becomes 0. म्हणजे इथे आपण first derivative find out करणार, that is s is equals to, find out the second derivative, first derivative, that is a ds upon dt. Its a derivative is a t square minus t minus 6. We have given that the condition, the velocity is equals to 0. We want to find out the acceleration. Also first find out the second derivative, पण इथे find out करणार. The derivative of t square minus t minus 6 is a 2t minus 1. But what is the condition when the velocity is 0? Means what? T square minus t minus 6 is equals to 0. This is the quadratic equation. Then you will get the value of t is equals to 3 and t is equals to minus 2. But time is not negative, and hence we take the value of t as a 3. Then what will be the acceleration when the velocity is 0? Acceleration किती आपल्याकडे 2t minus 1. Substitute t is equals to 3. Then you will get 2 into 3 minus 1 is equals to 5. Okay. Now the option A is correct here. Next example, the displacement s of a particle at time t is given by s is equals to t cube minus 3t square plus 6t plus 1. When its velocity at t is equals to 1 is given by. Okay. Now s is equals to, differentiate this with respect to t. Now here we have the velocity ds upon dt at t is equals to 1. Substitute the value t is equals to 1, then you have here that is equals to 3. आपल्याला काय फाइंड आउट करायचं होतं, तर त्याची velocity when the time t is equals to 1 and that is equals to 3, and hence option B हा या ठिकाणी कसा आहे तर तो करेक्ट आहे. Next example, the normal to the curve x square plus 2xy minus 3y square is equals to 0 at 1 1. First option A does not meet the curve again. B meet the curve again in the fourth quadrant. C meet the curve again in third quadrant. D. Meet the curve again in the second quadrant. Now see the solution. Differentiate this equation with respect to x first of all. Okay, then you will have the dy by dx, that is equals to 2x plus 2y upon 6y minus 2x. And at the point 1, 1, the slope of the tangent, that is equals to 1. Okay, and therefore the slope of the normal is a minus and the reciprocal. Therefore the equation of the normal is at the point 1, 1, and the slope of the normal is minus 1. Y minus y1 is equals to m times in bracket x minus x1, and this is the equation of the normal. X plus y is equals to 2. Now solving these two equations, that x plus y is equals to 2 and x square plus 2xy minus 3y square is equals to 0, then you will get here x is equals to 1 and y is equals to 1. This is the first point. And next, x is equals to 3 and y is equals to minus 1. Okay. Therefore, the normal at 1, 1 meet the curve again at the point 3 minus 1, which lies in the फोर्थ क्वाड्रंट. आता हे दोन्ही इक्वेशन कसे सॉल्व्ह करायचे तर ते मी पुढच्या स्लाइड मध्ये दाखवले, ते तुम्ही बघू शकताय. ओके, therefore the option B is a correct here, that is a meets the curve again in the fourth quadrant. पहिला कोऑर्डिनेट त्याने आपल्याला दिलेला आहे, तर पुढचा पॉइंट कोणता असणार आहे तर 3 मायनस 1 अँड विच इज इन द फोर्थ क्वाड्रंट, अँड हेच ऑप्शन बी इज अ करेक्ट वन. आता हे दोन्ही इक्वेशन कशी सॉल्व्ह करायची तर या पुढच्या स्लाइड मध्ये मी ते दाखवलंय, तुम्ही ते बघू शकता. एक्स प्लस वाय इज इक्वल्स टू 2, एक्स स्क्वेअर प्लस 2xy मायनस 3y स्क्वेअर इज इक्वल्स टू 0. Okay, this is a quadratic solid. Then you will have the two equation, x plus 3y is equals to 0 and x minus y is equals to 0. Okay, now solve this equation with x plus y is equals to 2 and x plus 3y is equals to 0. हे दोन्ही solve करणार. Also x plus y is equals to 2 and x minus y is equals to 0. Then you will get the required point. Means what? X is equals to 1, y is equals to 1, x is equals to 3 and y is equals to minus 1. या प्रकारे तुम्ही ते solve करू शकता. Next example. The normal to the curve x is equals to a times in bracket cos theta plus theta into sin theta, and y is equals to a in bracket sin theta minus theta into cos theta at any point theta is such that, okay, it makes an angle pi by 2 plus theta with the x-axis. B, it passes through the origin. C, it passes through, that is a into pi by 2 minus a, and the D, it is a constant, it is at a constant distance from origin. Now we'll see the solution. The curve is x is equals to a times in bracket cos theta plus theta into sin theta, y is equals to a sin theta minus theta into cos theta. Differentiate this with respect to theta. There is a parametric differentiation. Then you will have the dy by dx is equals to a times cos theta minus in bracket minus theta into sin theta plus cos theta. Here differentiation करणार, divided by this differentiation with respect to theta cos theta derivative minus sin theta, the product rule apply करणार, theta into cos theta plus sin theta. After simplification you'll have that is equals to tan theta. Therefore this is the slope of the tangent. Therefore the slope of the normal at theta is equals to minus cot theta, and this is nothing but the tan of pi by 2 plus theta, and hence the inclination of the normal is pi by 2 plus theta with the x-axis, and hence option A हा या ठिकाणी कसा आहे तर तो करेक्ट आहे. आपल्याला या ठिकाणी काय करायचं होतं तर आपल्याला स्लोप फाइंड आउट करायचा होता. टँजंटचा आपल्याला स्लोप मिळतो त्याचा मायनस अँड रेसिप्रोकल, दॅट इज नथिंग बट द पाय बाय 2 प्लस थीटा, अँड हेन्स the normal inclination of the normal with the x-axis is pi by 2 plus theta. Next problem. The normal to the curve x is equals to a times in bracket 1 minus cos theta, y is equals to a times sin theta at theta always passes through the point. Okay, now see this here, the given curve x is equals to a in bracket 1 minus cos theta, y is equals to a sin theta. Differentiate, this is a parametric differentiation. Dy by dx is equals to dy by d theta upon dx upon d theta. Then you will have dy by dx is equals to cos theta upon sin theta. This the slope of the tangent. Slope of the normal at theta is equals to minus sin theta upon cos theta. Now the equation of the normal is y minus y1 is equals to slope of the normal in bracket x minus x1. After the substitution you will have y cos theta minus a times sin theta into cos theta is equals to हे सिम्प्लिफिकेशन करणार, या कॉस थिटाने वाय मायनस ए साइन थिटाला मल्टिप्लाय करणार, मायनस साइन थिटा आणि एक्सला and minus a in bracket 1 minus cos theta multiplication करना, and after simplification you have x times sin theta plus y times cos theta is equals to a sin theta, and therefore it's a clear that it passes through the point a comma 0 means what the option C हा या ठिकाणी कसा आहे तर तो करेक्ट आहे. म्हणजे हे इक्वेशन मिळाल्यानंतर आपण हे पॉइंट या ठिकाणी सबस्टिट्यूट करणार and then he will get the answer from the options also. Okay, and hence the option C is a correct here. Next example, the area of the triangle formed by the x-axis, the tangent and the normal to the curve y is equals to 6x minus x square at the point 5, 5 is, we want to find out the area of the triangle. Now see this here, the P is a point, okay, at the point 5, 5, then y is equals to 6x minus x square, dy by dx is equals to 6 minus 2x. At the point P, the slope of the tangent is minus 4. Equation of the tangent at P is y minus y1 is equals to m times in bracket x minus x1. Similarly, the equation of the normal at the point P. मग त्या ठिकाणी स्लोप किती असणार तर 1/4, y minus y1 is equals to 1/4 in bracket x minus 5. This is the equation of the normal. Okay, the tangent and the normal meet x-axis at the point Q. Okay, suppose this is the equation of the tangent. When this tangent meet the x-axis, y coordinate is a 0, and if we simplify it, then you will get the point Q 25 by 4 comma 0, and when this is the normal, when it meets the x-axis, then y is equals to 0, then you will have the x is equals to minus 15. Okay, these are the 3 points. First is a P, Q, R. We want to find out the equation of the and that we want to find out the area of the triangle, and that is therefore area of the triangle PQR is a numeric, it's a numerical value is equals to 1 upon 2. आपल्याला या टाइपचा फॉर्म्युला माहिती आहे. when three coordinates of the triangles are three vertices, the coordinate of the three vertices of the triangles are given, then its area is a x1 y1 1, x2 y2 1, x3 y3 1. Okay, 1 upon 2, and if you simplify, then you will get its area, which will take always the positive area. आपण हा कायम पॉझिटिव्ह घेत असतो. therefore the area of the triangle is a 425 upon 8, and hence option A हा या ठिकाणी कसा आहे तर तो करेक्ट आहे. नेक्स्ट एक्झाम्पल, the curve y is equals to ax cube plus bx plus cx plus 5 touches x-axis at minus 2 0 and cuts y-axis at the point B where the tangent slope is 3. Then the values of A, B, C are. Okay, a curve त्याने दिलेला आहे. It touches the x-axis at this point and cuts the y-axis at the point B. Okay, where the slope of the tangent at that point is a 3. Then find the value of A, B, C. Now see this here. The curve y is equals to x cube plus bx square plus cx plus 5 different at the point minus 2 0 lies on this curve. Therefore, if we substitute here their values, if we substitute y is equals to 0 and the other points, then you will have here minus 8a plus 4b minus 2c plus 5 is equals to 0. Okay, now this condition is satisfied only by option 2 only. Okay, option 2 मध्ये या सर्व conditions satisfy होतात. Otherwise the full problem can be solved like this. Okay, first let the tangent at the point B, the curve cuts y-axis at the point B, therefore let that coordinate of that point B is, त्याचा x coordinate किती असणार आहे तर तो 0 असणार आहे. therefore B lies on this curve, and if we substitute here x is equals to 0, इथे x is equals to 0 जर टाकला, then you will have y is equals to 5. therefore the coordinate of the point B is 0 5. Also dy by dx at the point A is equals to 0 and dy by dx at the point B is equals to 3. Okay, आता जर समजा आपण इथे dy by dx at the point A means what, here जर आपण हे differentiate केलं, then what you will get here 3a x square plus 2bx plus c. And if we substitute x is equal y is equals to 0, then dy by dx is equals to 0 मिळेल तुम्हाला. आणि इथे जर समजा पण dy by dx at the point b, okay, means what 0, 5, then you will have the dy by dx is equals to 3. आता ते कसं या प्रकारे इथे सॉल्व करून दाखवले. y is equals to dy by dx at the point a minus 2, 0, dy by dx is equals to 0. If you substitute, then you will have the equation in terms of ABC, 12a minus 4b plus c is equals to 0 at the point B. Okay, at the point B, dy by dx is equals to, we have the, its a value is a 3. Okay, the value त्याने आपल्याला किती दिली तर 3 दिलेली आहे. and at the point B x is equals to 0. इथे x is equals to 0 जर आपण substitute केले, then you will have the c is equals to 3. Substitute the value of c 3 and solve this first. That is the equation 12a minus 4b plus 3 is equals to 0. And the second equation, that is a minus 8a plus 4b minus 1 is equals to 0. If you solve these two equations, then you will get the required point. Okay. Now the next problem. The angle between the tangent at which the points on the curve y is equals to in bracket x plus 1 into x minus 3, where it meets the x-axis is. Okay, angle between the tangent आपल्याला find out करायचं आहे. When the curve meets the x-axis, then y is equals to 0. Then you will have, this is the quadratic equation. X square minus 2x minus 3 is equals to 0. Therefore, the values of x is minus 1 and the 3. The tangents are drawn at the point minus 1, 0, and the another point is a 3, 0. Okay. For the curve, dy by dx is equals to, okay, if we differentiate this, the derivative of x square is a 2x and derivative of minus 2x is a minus 2. At the point minus 1, 0, you will have the slope minus 4, and at the point q, that's the slope किती असणार आहे, that is equals to 4. Okay, and hence if you substitute x is equals to 3, then you will have 6 minus 2, then therefore dy by dx slope of, or the slope of the tangent at q is equals to 4. The first slope is minus 4 and second slope is equals to 4. Therefore, the required angle between the tangent, that is equals to tan of theta is equals to in bracket m1 minus m2 upon 1 plus m1 into m2, or theta is equals to tan inverse of, this is the m1 minus m2 upon 1 plus m1 into m2. If you simplify this, then you will have the tan inverse of 8 upon 15, and hence option B हा या ठिकाणी कसा आहे तर तो correct आहे. Now the next example. The normal to the curve x is equals to 3 times cos theta minus cos cube theta, y is equals to 3 sin theta minus sin cube theta at the point theta is equals to pi by 4 passes through the point. Okay. Now first, this is the x is equals to 3 times cos theta minus cos cube theta, y is equals to 3 sin theta minus sin cube theta. Again, this is a parametric equation. Dy by dx is equals to dy by d theta upon dx upon d theta. After the simplification, you will have the minus cos cube theta upon sin cube theta. Dy by dx at theta is equals to pi by 4 is equals to minus 1. Okay, this is the slope of the tangent. Therefore, the slope of the normal at theta is equals to pi by 4. It's a minus and reciprocal करणार आहे, that is equals to 1. Okay, when theta is equals to pi by 4. Therefore, the x coordinate, या ठिकाणी we will substitute here, that is theta is equals to pi by 4. Then cos of pi by 4 1 by root 2, cos cube of pi by 4 is its value, म्हणजे ते किती 1 by root 2 त्याचा क्यूब येणार, that is 1 times 1 upon 2 times 2 1 upon 2 root 2, and after simplification you will have x is equals to 5 upon 2 root 2. Similarly, y is equals to 3 by root 2 minus 1 upon 2 root 2. Substitute here, theta is equals to pi by 4. Overall, you will have y is equals to 5 upon 2 root 2. तुम्ही ते simplification करू शकताय. Therefore, the normal at theta is equals to pi by 4 is the equation of the normal. Y minus y1 is equals to m times in bracket x minus x1. Slope किती येते तर नॉर्मलचा तर 1 आहे. Therefore, we directly write y minus 5 upon 2 root 2 is equals to x minus y upon 2 root 2. And after simplification, okay, हे काय आहे ते? This is the similar terms या दोन्ही साईडला आहे. Therefore, x minus y is equals to 0. And this normal passes through the point 1, 1. Okay. And hence option D हा या ठिकाणी कसा आहे तर तो correct आहे. Okay. And in this way, we have completed all these 10 examples. Now we'll see in the next video. Till then, goodbye.